so what we looked at last week was different types of triangles. We looked at angle, angle, side, and we used the law of sines to solve for the other three missing parts. The one missing angle and the two missing sides. Then, we didn't really discuss it, but we also did this one. But is that one that you learned from geometry? It's not. If you turn that around, it's a bad word. And the bad word actually doesn't work. These are the ones you studied in geometry. So let's talk about this one. That's what we're going to look at first for today. We're going to look at two examples of those. All right, SSA. So SSA means you know this side, you know this side, and then you know this angle down here. So if that's the case, you don't know if it's this triangle, you know this side and this side, and you know this angle, but guess what? If the measurements are accurate, it could be that triangle. It could be a smaller side. So you actually have the possibility of two triangles. You also have the possibility of no triangle. Let's say you know this side, you know this side, and you know this angle. Well, the problem is, if this angle's not right, this side's not long enough. It doesn't work. It doesn't make a triangle. So this is called the ambiguous case. Ambiguous means open to one or more interpretations. So that's what we're going to be looking at right now. Whoops, get this back here. Okay, I'll just set this over here in case we need to pull that out again. All right, so we've practiced with this one. This is a geometry theorem that you learned, so we don't have to worry about that one. But anytime you have this, it's not a geometry theorem you learned. You have to check and see, is it even possible? Is it just one triangle, or is there a possibility of two triangles? All right, so that's what we're going to look at. So the next example we want to look at is when there are two examples, and I want to show you how you can figure that out. All right, here we go. So this is C, A, B, and little b is 16, and little a is 10, and this side is 30. All right, so basically what you need to look at every time is what kind of triangle is this? Well, it's a side, connecting side, and then an angle. So this is an SSA, and in trig we always write it backwards because we don't want to write a bad word, okay? All right, so what we need to do is to see, let's find out, what could it be? All right, so what we're going to do is we're going to set up, we'll do B to B. So 16 over the sine of angle B is 10 to the sine of angle 30 degrees. So you're going to solve it just like you've been doing. So 16, I think I like to put the variable on this side, so I'm going to do it this way first. 10 sine angle B is 16 sine angle 30. Divide both sides by 10. All right, so if you put this in your calculator and work it all out, we can actually do it in our head. What's the sine of 30 degrees? 1/2. What's half of 16? 8. So this is 8/10, which reduces to 4/5 or 0.8, depending on how you did it. All right, so how do we find the angle that gives us this sine value? Well, let me grab my calculator. So hopefully you remember, that's when you use your inverse sine. So we're going to use inverse of the answer. So whichever answer you want to put, you get the same every way. That gives you the angle. All right, so I will do inverse sine. By the way, we're in triangle, so make sure you remember you have to be in degree mode. I'll just make sure I am. So second sine, inverse sine of 4/5 or 0.8. And what you'll end up getting there is approximately 53 degrees. Your book is having you round your angles to the nearest whole number, so that's what I did. Now, what you've got to think about is, this is that SSA. It's that one, which is not really a theorem. So it's possible that this is the only answer it could be. But if you think about your circle, your unit circle, if B is 53 degrees, it's about right here. And that means the sine is 4/5. If you think about it, that length is 4/5. It's in a unit circle. But what we have to realize is that could be the answer. And that is the only answer because of the restricted inverse answers. It could be. But in reality, if you think about it, you could go here, but the truth is you could go here. That would also give you 4/5. So this would be 4/5. This would be 4/5. So therefore there's actually two answers. So how could I get this angle that goes all the way over here? Well, if from here to here is 53, that means from here to here is 53. So I take my whole top half, the 180 degrees, subtract the 53 degrees, and that would give me a second value for B. So if you subtract that, that would be 127 degrees, okay? So we've got 53 degrees is one possibility, 127 is one possibility. So let's go back up here and let's see, is it possible? Could it actually work? So you redraw this triangle. This is what was given to us. We know this is 30. Now what we have decided is this angle B could be 53. Let me use a different color. So this could be 53 degrees. But if we looked at the second possibility, this could be 127 degrees. Now, does that work? If you add these two, you get what? 83? Subtract from 180, and you would get 97. Well, that works. Those add up to 180, so that's good. What about this? 30 degrees plus 127 degrees would be 157 degrees. So that would be what? 23? So that was C. And could that work? Yeah, it could. Because you could, if you add all that together, sure enough, you get 180 degrees. So we're going to have two sets of possible values to solve this oblique triangle. Remember, oblique means it's not a right triangle. All right, so we've got, let's see, we've got the three angles on both. I'm just missing a side. I'm missing side C. So for this one, you're going to have to use these values. So C, this right here is C. C over the sine of 97 degrees. And I would use this one because that was actually rounded off. So let's use this one. 10 over the sine of 30 degrees. All right, cross multiply. C sine 30 degrees equals 10 times the sine of 97. Divide both sides by the sine of 30 degrees, which is, hopefully you know, 1/2. So C is approximately, and you'll just pop all that in your calculator. Divided by technically 1/2. Okay. So you end up with 19.9. It's approximately 19.9. So this is the other value that's missing. Then you have to also solve this one. If we solve this one, you would have, again, this is C, what we're looking for. So C over the sine of 23 degrees equals 10 over the sine of 30 degrees. This is the law of sines. So doing the cross products, divide both sides by the sine of 30 degrees. So C is approximately, and I've already done it, 7.8. 7.8. Okay? So that's part of the lesson for today is, first of all, understanding that if you have an SSA, funny things can happen. You could get just like what we did on last week. We only got one answer. Now we've gotten two answers, okay? So there's also a possibility that you get no answer. So let me show you one of those. All right. So I'm actually skipping. If you made copies of the notes, I'm actually skipping Roman numeral number 3. I'm going on to Roman numeral number 4 so you can see the last type of ambiguous case. All right, so A, B, C, A equals 7, C equals 16, and this is also 30 degrees, okay? So the first thing we're going to do is notice, side angle. It's called that ambiguous case. It's open to more than one interpretation. It could be impossible. There could just be one triangle that could possibly work, or there could be two triangles that could possibly work. So you just have to kind of go for it and see what happens. All right, so let's do it. 7 is to the sine of 30 degrees. And since we know the 16, we'll have to use C. So we'll do the cross products. Divide both sides by the sine of 30 degrees. So C is approximately, so you put that in your calculator. And you can put it in the calculator, or I just want to show you one other way to do it. It kind of saves you a little bit of work. If you want to know what C is, remember it is the inverse sine of that. And you could get that answer, and that would be fine. So you can, if you don't, you can get that answer and then do inverse sine, or you can just do the inverse sine of that expression. It's really up to you. But I'd like for you, if you have your calculator, let's see, here's mine. I'd like for you to see what happens. So if you do inverse sine, helps if you turn it on. Inverse sine of 7 sine 16 degrees. And that's the whole numerator, so make sure you put your parentheses around that. Divided by 30. Oh, sorry, sine of 30. Left out sine, can't leave that out. Okay, so I want you to look at this closely. What happened? We got an error. That means this is an impossible triangle. There is no way that you can have an SSA that looks like this. These sides don't match with this. So this is kind of like the triangle where the one side was too small. It was not big enough. It didn't make the triangle. So this is an impossible triangle. So your answer is impossible. It can't happen. You can't have a triangle like that, okay? So again, if you're looking at your notes, that's actually Roman numeral number 4. Now I'm going to scoot back to Roman numeral number 3. So I just wanted to say, this one we did before, and we started this before, now we finished this. So I want to show you one other type. Okay, so this is technically Roman numeral number 3. Alright, so this is it's J, I'm sorry. J, K, L. K is 39 degrees. J is 73 degrees. And we happen to know that side, which would be L, is 14. So we don't know K side and we don't know J side. That's what we're going to be looking for. And we're also going to be looking for this. So what kind of triangle is it? Is it an SSA? No, it's not. It's an angle, side, angle. Well, guess what? You learned that one in geometry. This one is angle, side, angle. So just to go ahead and give you a little warning, these are the 3 that you can use to using the law of sines. These are the 3 types of triangles. ASA, that's this one. AAS, we did last week, and then this SSA, which we started last week and finished today. Those are the 3 that you can use law of sines. Now soon, we'll be learning the law of cosines. It'll be a few days, but so right now, these are the types that you'll have, okay? All right, so your first thing you typically do is, since you know 2 angles, just go ahead and add these 2, subtract from 180, and get the one that's missing. So that would be what? 112 from 180, so 68. I'll use that other color so it stands out. So 68 degrees. Okay, so that's that one. Alrighty, and then let's go make sure I subtracted right. I did. Okay, just checking. Alright, now we can use really any of them. All 3 of these angles are exact. But we're going to have to start with this one because this is the only side we know. So I would say 14 is to the sine of 68 degrees as, which one you want to do? Doesn't really matter. We'll just do J. J is to the sine of 73 degrees. So cross multiply. Good old cross products. Love those. And then divide both sides by the sine of 68 degrees. So J, put that in your calculator. And I've already done it, and you could check it out just to make sure you got it right. I got 14.4. And we're rounding. The way we're rounding is the way your book is having you do it. Your angles are to the whole number, and your sides are to the tenths. Okay? And then just to find the K, we'll just start from what we knew for sure, because that's rounded, so I'd rather not use that one because then it won't be exact. So 14 is to the sine of 68 degrees, so I'm using this combination, and now I'm going to use these 2, the K's. So K to the sine of 39 degrees. So do your cross products. And then divide both sides by the sine of 68 degrees. Make sure you're in degree mode. And you would find out that K is approximately 9.5. And one thing you can always kind of double check yourself. Remember that another theorem you learned in geometry, when you have a triangle, your largest angle is opposite the largest side. Your median angle is opposite the median side. And the smallest angle is opposite the smallest side. That's called the hinge theorem. The more you open up a triangle, the bigger that side is across from you. So that was something you learned in geometry. Alrighty, that's all for today. Tomorrow we will continue working and looking at some more types of problems that you can use for law of sines, and then there's another theorem too that we're going to be looking at. So, alrighty, I'll get it on the computer.